Okay, good morning. Welcome back. We're going to hope that projector doesn't sound healthy, does it? Oh, wait a second. There we go. Okay, let's update where we're at here. A couple of us were talking about the cup stacking quiz when you walked in. I'll take a look and see how that went. Some of you struggled with that. Who got, is it 10? 10 out of 10. Anybody? Only one of you? So the quiz does work? Yeah. Yeah? Okay. So I'll take a look. If you want to talk about your computation, like this is how I came up with this answer, blah, 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 I can take a look at it with you too. I'm pretty sure I have the correct answers in that quiz. I'm telling you, it's your fault, not mine. But hey, I've been wrong before. So we'll see how that goes. Okay, couple of things I want to do today. First thing I'd like you to do, we're going to talk about section... where are we at here? Friday, September 13th. Section 1.7, fitting linear models to data. Okay, so I got a couple activities we're going to do that today. The first one is a Desmos. Go to Course Docs and Links, scroll all the way to the bottom, find where it says Desmos charge. You guys see that? So same thing, go ahead and log in and basically watch the video at the beginning and try to go through the steps and see if you can figure out what's going on. We'll spend a good 20 some minutes on this.
Mine pops up.
It should be is it a video or is it a, oh, it's not. The video comes later. I'm sorry. It's just a picture of the iPhone, right? The video's at the end. I'm sorry.
I think this is like a normal iPhone.
I don't know. It looks like an iPhone 6. Yes, I still have an old iPhone. You guys are probably like, iPhone 6?
No, that's old.
My wife has an iPhone 5. Now that's a dinosaur. So what we're doing, all we're doing at the beginning is guessing. We're making a prediction. You don't have to think too hard. Everybody get a guess put in yet? Go ahead and sketch what you think the graph is going to look like. Try to be as precise as you can. Our predictions all fell in between 30 and 120. The lowest person predicted 30, the highest person predicted 120. So that's a pretty big gap, right? Let's see how we do when we actually get an answer towards the end. Now remember on step 3, you're actually supposed to give a number. What number goes in there? Then explain your thinking. Okay, I'm going to pause you for a second. Take a look at all the graphs that you guys did in step 2. Very, very similar on all of them. Okay? Pretty much all of you drew a straight line. Now, it's possible, Landon and Matthew and Dalton, you were trying to draw a straight line with your mouse, maybe. Or maybe you wanted it to have a little curve in there. You can see some of the others use the straight line tool. That's fine. But in general, do we all agree that it looks to be linear? It looks to kind of be growing in a straight line. If we can agree on that, okay, then as we analyze this chart, this table, if we look at this table, if we think it's linear, then we would just kind of draw a line, or we would talk slope, and we could make a prediction on what this number was going to be, right? And most of you did that, although some of you explained it better than others. Here's a few that I liked. Look at this first one. I think it's going to be 37% because it took 8 minutes to go up 9%. So at 16 minutes, it should go up 18%. Is that a linear relationship? Sure it is. Basically saying up, that's slope is rise over run, right? So if it's going to go up 9% over a run of 8 minutes, shouldn't it go up 18% over a run of 16? Isn't 9 over 8 the same slope as 18 over 16 if you reduce it? So the slope is the same. So that person is thinking slope. Here's another one. In 8 minutes it charged 9, so in 16 minutes it would charge 18. These two are saying the same thing. Okay? What's this person talking about? It goes 5, 6, 7, 8. Whether or not that person is talking about, let's look at the chart again. Up 5, up 6, up 7, up 8. So they're saying from the time, the percent is always going to be higher than the time, increasing by 1. So I don't know if that's necessarily, it is linear in a sense. I would say this person's doing a good job of looking for repeated reasoning or looking for structure, although I don't know if the explanation is necessarily a linear slope explanation, but a good way of seeing a pattern. That person is seeing a pattern, right? So a lot of you got 36, 37, 38, somewhere around there. Okay, I'm going to let you keep working. You found out in step number 4 that the actual answer was 38, right? So if you were somewhere close to 38, I'd say you did well. If you were nowhere close to 38, then you weren't very good at recognizing the pattern. In step 5, by the way, the idea is that you can grab that red, I can't do it with mine. You can grab the red line and move it, correct? Did you guys figure that out? I can't, it doesn't work when I try to do it. Maybe I can't do it from my screen. Anybody having trouble on step 5 getting the red line to move? Hannah, your red line didn't move on number 5. You can try to fix that. There you go. Oh, wait a second. Yep. You see what I was talking about there?
Yeah, but like, why?
Can you get the, so the idea is, can you get the red line to kind of lay on top of those 4 blue ones? Oh, number 5 wanted you to type,
Yeah.
not drag the line, right? I'm sorry. So the idea is, could you, wait a second. I am all screwed up. Number 4, go back to number 4.
Let me put this back in.
4 is the one.
4 is the one, I'm sorry. The idea was to take those 2 red dots and try to get them, there you go, try to get them to go over the blue as much as you can. Then in step 5, you don't have to guess at it, you get to use that to help you.
I was confused.
Yeah, so was I. So step 4 is where we're moving the red line. Step 5 then, it will show you, hey, here's the red line that you built. Now you can use that red line to help you make your calculation. Yeah. Gage, double check your step 6. I don't like your step 6 is what I'm trying to tell you. Step 7, let's see. Dalton, be more specific on step 7 for me. Gage, more specific on step 7. Okay, I'm going to give you another minute to finish for those of you that are still going. Okay. So remember we started out with 30 to 120, and then it looks like our highest here was 115, our lowest was about 70. So we narrowed the gap, right? We went from about 70 to 115. So this was prior to doing any math. This was just trying to guess, right? And then when we do a little bit of math, we do a little bit of data, we do a little bit of problem solving, we made some headway, right? Like we narrowed the gap. Our guess became more of an educated guess, right? Now, when we interpret this equation, everybody had a little bit different equation on step 6 because depending on how you dragged your red line, everybody's could be a little bit different, but you should have been really darn close to 1 point something x plus 5 roughly, okay? And I think all of you interpreted this pretty well. This is y equals mx plus b. So the slope, it is the percent of charge per minute. Percent of charge per minute, right? And then what does the 5 mean? And that was in step 7. Dalton, you put it's where it crosses the y-axis. Correct. What does that mean? That's why I said be more specific. When it crosses the y-axis is at time 0, meaning that's where we were right when we went to plug it in, right? So what does that mean? It's the percent that the phone started at, or the percent at the beginning, or whatever it is. It was at 5% when we decided to plug it in, as opposed to being at 0% or at 12% or something like that, right? So hopefully you can make sense of what that number means in terms of slope and what that number means in terms of a starting point. Now, what did you guys find out when you revealed it? It looked like it was going to be a nice straight line, straight, and then what happened? This happened, right? So it's like everything looked like you had it going, and I bet all of your calculations came up a little shy, didn't they? You put 80, you put 90. What was the actual answer? 140. Like nobody had 140. Does that mean you all did this problem wrong? No. Okay? We only had data that got us so far, and that's all we had to rely on. So the best estimation that we could have made is that this charging is going to continue going in the linear pattern that it has started on. We thought it was linear. Everything looked linear. Did it hold up? No. Did we have any idea that it was going to turn nonlinear at the end? No. So unless you graphed it, but you were only given 4 data points all the way back to here, right? You were only given these 4 points. Okay, so as far as I'm concerned, that looks like it's going to be a straight line. Now, if they would have given us another point over here or over here or over here, that would have changed things, right? But we weren't privy to that information, so what were we supposed to do, right? I would have done the same thing you guys did. I would have assumed that it was perfectly linear, and we would have went for that. So the idea here is that you did linear modeling here. You took data, you fit a line to it. It just turns out that in the end, this one somebody wrote wasn't quite as linear as I thought it was going to be. One of you wrote on there, which is, yeah, exactly right. So let's talk the Google Pixel really quick. There was a bunch of guesses here. A lot of you said 25%, because 25% of the way, a half hour would be 25% of the total time, right? 1/4 of it. So if you guessed 25%, you are assuming that the Google Pixel is going to make a straight line and continue to make a straight line all the way up to 100, right? But what did we just learn about the iPhone?
Slows down at the end.
Yeah, it's not linear. So the question is, do you think the Google Pixel is linear the whole way? Or do you think it's going to be like the iPhone and it's going to slow down at the end? We don't know, right? Did anybody think it might slow down at the end? Or did everybody put 25 minutes?
Put 30.
You put 30. Dalton put 30.
But for the first 30, shouldn't it be linear? At the end is when you lose.
Good point. Good point. So let's say it was linear the entire time. If it was linear the entire time, then our graph would look like this red one. That was a terrible line. I tried to draw that straight. Do you guys agree if it was linear, it would look like this one? The red one? Okay. So if it was linear, let's ignore the black one. What percent charge would I be at there, 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 and there? Can you guys kind of see that? If it was the red one, what would my answer be? 25%. Do you guys agree that's 25%? And then this one would be 50%. And then this one would be 75. So if you think it's going to follow the red line, what's your answer going to be for the Google Pixel? 25. And a lot of you said that. If you don't think it's going to be, if you think it's going to be, just like Dalton said, it's linear at the beginning. But wouldn't the slope have to be greater? Because if it's going to slow down later, right? If it was this linear at the beginning and it slowed down later, it would taper off like this and it would take even longer to get there. How you doing back there, Dalton?
You got me on that one, Bob.
But you actually put larger than 25, didn't you? Didn't you? Oh, I thought you put 30. Oh, I read the beginning of your thing. Okay. So anybody who put larger than 25, you're probably thinking it's going to follow more of the black line as opposed to the red line. Okay? Are you guys dying to find out? Let's see how long it takes. Here is our Google Pixel. This is a Google commercial, I think, is what this is. The OnePlus 3T, I've never heard of that phone.
Yeah.
What is that? Is that a Google one?
Must be.
But you guys have heard of the Google Pixel?
Yeah.
Anybody got one? You guys all iPhone people? Yeah, me too. Okay, so here we go. The Google Pixel is the one on the right. So that's really the only one we're concerned with. So now we got to watch it for 2 hours. Boy, this is going to be a long class today. No, we're going to fast forward it. Okay, let's going to stop it at a half hour and see where it was at. Watch. Here comes a half hour. 49%. Nobody guessed that high, did you? So a fourth of the way, it was already half charged. So it's really going to flatten out. So it's even going to be worse than the iPhone. It's going to go like this, right? There it was halfway, 71%. So it took an hour to get to 70%. The last 30% is going to take an additional hour. Why do phones flatten out as they charge, as they get close to 100%? I have no idea. But it's kind of a fun math activity, I think. So what? There it is, 2 hours. This one apparently only took an hour and a half, so that one charges faster. Whatever. Okay.
It's on dash charge. Don't forget about that.
Oh, that's what they're doing, the dash charge. Okay. Let's do another activity. I hope you're getting a feel for linear modeling, and I'm going to give you another activity to help you with that. Underneath the Desmos link in Blackboard is a linear regression template. You guys see that? Go ahead and open that. It is a GeoGebra file. What I would like you to do, remember back in step 4 of the cell phone charging when you tried to make that red line fit those 4 blue dots? I want you to try to do the same thing with the green line and these 4 blue dots. So how are you going to do it? The B slider is your y-intercept. Notice that just moves it up and down. Okay. The M slider is your slope. So I want you to manipulate M and B and try to get it to go through. Obviously, these don't make a straight line, right? So I want you to try to get the line that kind of goes right through the middle of all 4 of them. All right? Now, one hint, you can use your mouse or your trackpad to slide these, but if you want to be really precise, use your left and right arrow keys. See how I can change the slope 1/1000th at a time? Then you can be really, really precise with it. Click on it. what I'd like you to do is get it relatively close. I'm going to give you 20 more seconds to get it as close as you think you can. Has everybody got it open and able to do the sliders?
Mine's not working again. I think I'm just gonna have to go down to
The GeoGebra?
yeah, it's just, I opened it up.
What?
It's just a blank one again. It's weird.
So somehow you're
I think I'm just gonna have to go down after class.
open. The help desk isn't going to be able to help you with
You
this.
don't think so?
No, they don't know anything about this software. Something, why is it? Okay, here, okay, do this once for me, humor me here. This, first of all, this is a different
Yeah.
GeoGebra.
Yeah, I don't know what classic.
So, okay, I'm just going to close all these. When you open it,
Don't save.
close all windows. When you open GeoGebra, type it in here, Geo. Okay, so you have the app. You don't have. Go to geogebra.org. Hold on a second. Let's see what opens here. Now I'm not sure. Let's see what opens here. No, that should be correct. Okay, try this.
That is right now?
Yeah, I don't know. Try. Can we right click on that and save it? Save link as. Can we save? Save that to your desktop.
Let's see if we can.
And then try to open it. Now go File, Open
This could work.
from your desktop.
Open that bad boy. Yeah. Hold on.
I don't know what's going on
Hold
there,
on. I don't
but
know either.
okay.
Hold on.
Okay, does everybody have a line that's sort of good? It doesn't matter how good it is right now. We're going to refine this. Okay, I'm going to show you what we call linear regression or least squares regression. We're going to kind of do this not by hand, but we're going to do it manually just so you can see what this actually is. So try to follow along here. There's a lot of steps here. What we want to do is we want to find the distance in between your green line and each point. So like that distance right there, and that distance right there, and that distance right there, and that distance right there. Just a straight up distance is what we're looking for. So the first thing we need to do, go to your perpendicular line tool. That's your fourth button there. You see that? And I want to do perpendicular lines from each point down to the x-axis. So I got a perpendicular line. I'm going to click on point A, and then I'm going to click on the green line. That did not work. I clicked on not the green line. I'm sorry. Duh. The x-axis. A perpendicular line from point A, and then click on the x-axis. See how it's a straight line up and down? And then do it on point B, perpendicular to the x-axis, point C, perpendicular to the x-axis, and point D, perpendicular to the x-axis. Everybody okay with that? Then what I want is those black perpendicular lines that you just put in. Try to put in a point where that black line crosses the green. So I'm going to click on the intersect, and I'm going to go where the black crosses the green, and now I have a new point called E, and notice it's right underneath my A. I'm going to end up measuring that distance AE in a second here. So when I do the intersection there, I've got B and F are apart from each other. When I'm going to move this just a little bit because it's right on top of my C. Let me just move that for the meantime. I'm going to do a perpendicular line, right, or a intersection point right there and right there. Does everybody see why I put in points E, F, G, and H? I'm going to use points E, F, G, and H now to make little segments. Instead of full lines that go forever, I'm going to make little segments. So now back over to your line tool, do a segment. So I'm going to connect A and E with a segment, and it's segment K. I'm going to connect B and F with a segment, C and G with a segment, and D and H with a segment. And now that I've got them connected, I'm going to go over to the blue dot on those original lines that I put in, and I'm going to uncheck them so I don't have to look at them because they're cluttering up my screen. So now what I've done is I've made segments in between each blue dot and my line. How we doing? Anybody need help? We want 4 segments. Mine are K, L, N, and P. Yours would also be that if you did it in the same order that I did it.
Somehow get rid of the perpendicular.
Yeah, don't delete them though. What I did, we don't want to delete them because these points are defined in terms of those lines. But what I did is I just clicked on the blue dot to turn them off so I didn't have to see them. They're still there. I'm just hiding them so they don't clutter my screen. Does that make sense? Anytime you want to toggle the view off on something, you can just click on the blue dot to get rid of it. Looks like you lost your.
Yeah, like my whole graph disappeared.
Go to view.
I didn't even get rid of it.
Click on graphics, right there. There you go. And then your properties is so big, there you go. Now go out to view and click on algebra, and get your algebra screen back up there. There you go. Okay, I know that's a lot of steps. So we're going to have these segments K, L, N, and P. If I scroll down on my algebra window, they'll be down there. K, L, N, and P all have certain distances, right? And as I move that green line around, those distances are going to change, correct? Anybody having trouble? Segment. So did you already make a segment from H to A?
No, not yet.
Yep. So you can click on A and click on H, and there it is. Now do it from B to E, and then do it from F to C, and then do it from D to G. Okay, now go over in this H, I, J, and wherever your other one went. Let's just click on the blue dot and toggle them off. Click your grabber button first. Toggle them off so they're not there anymore. Oh, you already did it. Oh, no, you did it twice. One more. Then what's that one? Scroll down. It must be down somewhere. Scroll down on your algebra window. It's that one. There. So now you just have segments like I do, right? Does everybody have segments?
No, I can't get the perpendicular lines to go straight.
Okay, so click on A, and then click on the x-axis. Oh, wait. Yeah, okay, perpendicular line. Click on A. Well, it was like it was highlighted already. Now the x-axis. Nope, the x-axis. Yep, there you go. So hit undo or delete. Yep, that's fine.
Okay.
There you go. Okay, for those of you that are kind of waiting, what I'd like you to do, so we have these 4 lengths. Mine is 1.15, 2.118, 0.589, 2.12. Yours are different, right? Depending on where you put your green line, everybody's is going to be a little bit different. But I have 4 lengths, and my 4 lengths are K, L, N, and P. Identify what your 4 lengths are. What are the letters? If you did it in the same order that I did it, yours will also be K, L, N, and P. Okay? So this whole process is what they call least squares regression. What we want to do is we want to take the square of each of those lengths. So 1.15 squared, 2.118 squared. Okay, we're going to square all of them, and we're going to add them all together, and that's going to spit out some number. Okay? So I'm going to make a new variable. I'm just going to call it my initials. I'm going to call it JW. You can call it your initials. I'm going to say JW equals, okay, what do I want? I want the sum of all the squares. So I'm going to say it's going to equal K squared, that was my first segment, plus L squared, plus N squared, plus P squared. And I'm going to produce a new number, which is the sum of all the squares, and I called mine JW. And I'm going to pull it out here so I can see it. I'm going to drop it and drag it. Right now, my sum of squares is 10.66. And notice, when I start changing my M and B to move my line, do you see how that changes the length of those little lines? So if I change my M and I change my B, and notice my JW number is changing with me as I do it. So here's your goal. Your goal is to get that number Okay? You got to get that number. It's the sum of the squares of those 4 segments, right? Once you get that number, your goal is to move M and B until you can get that number as small as humanly possible. We want that number to be tiny. The smaller that number gets, the better your line fits inside of the 4 data points. Are you following?
What do you do at the end of this equation?
Hit enter.
Did it say?
Yep. Illegal. Oh, you have 2 ms equals k squared plus l squared plus n squared plus p squared. Something. You have a space or something in here. What happened here? Plus. ms equals k squared plus l. Oh, yours are q, r, s, and t. Yours are different than mine.
Oh.
You see yours q, r, s, and t? So you got to go q squared plus r. Yeah. You might have different letters labeling your 4 segments, depending on the order that you did all of this.
How can I get rid of these lines? So I just have this like
So see, like this is line I and line J. Go over and find, and just hit the blue button. Perfect. It's not important that you get rid of them, but then you don't have to look at them. Yeah. So where's your other? Yep. It's G and H now are the other ones that you want to get rid of. Scroll up on your G and H. Yep. So one thing that's going to help you a little bit here is where is your, what in the world? Okay. When you're zooming, if you it seems like your zooming gets you screwed up. If you zoom, if you just grab the crosshairs, that'll help you move the screen where you want it. I'm just clicking and holding, and then you can always do one at a time. Like you can go like that, and you can go like don't do what I just did there, because that tends to like screw up your screen.
I don't know why this algebra bar is so huge either.
Yeah. So you can fix that. You hover over it like come on, that. Click and hold, right? And then you can go to options and font size, and you can make your font smaller if you want to. I make it big because I like students to be able to see it on the screen. Yep. Did everybody get this number? Were you able to spit out a number? Now, if you get, like my green line it's not bad right now. Do you guys agree? Like it sort of fits. So you should have a number that is, I don't know, around 2 or 1.7 or 1.9 or I don't know. Has anybody really got it like accurate? Does anybody have confidence like my green line really fits nicely? Anybody? Somebody throw out, well, first of all, raise your hand if you have a number on your screen. You actually got your computer to calculate it. So what's your number right now?
1.95.
1.95. What's yours?
1.721.
Wow. I'll come back to that. What's yours?
1.852.
Okay. He's the winner so far. 1.721.
1.943.
1.943.
1.729.
Wow. Very good. I can tell you that the lowest you're going to be able to get this is to 1.712. So you guys are really close. Okay? What I want you to do before you leave today is I want you to be able to get that number as low as humanly possible. If you can get it down to 1.712, then you can stop. If you don't get it to 1.712, don't worry about it. But what I want you to try to take away from this, by the way, there's a way that our computer can do this like that. And that's what we'll show you first thing in class on Monday. We don't have to go through this whole darn process and do it by hand and measure, blah, blah, blah. I'm showing you where this least squares regression concept comes from, okay? But like I said, there's a command in our computer that will instantaneously give us the line that gives us the smallest least squares regression. And that's what we'll do first thing in class on Monday when you come back. We got 1 minute left. What we're going to do then on Monday is we'll talk briefly about your project, save this. Okay, save this file so that if you want to come back to it after class or pull it up again Monday morning when we come back, you can prove to me that you got it to 1.712, and then I'll give you a pat on the back. But we will talk about this, and then we're going to do kind of a project activity that I'm going to give you. You probably won't finish it in class on Monday, but I'll give you most of Monday to work on it. And it's going to very much involve what we're doing right now with trying to get a line to fit through some data. Okay, any questions before we break? If you're having some GeoGebra trouble, stick around. I'll help you out. Otherwise, have a good weekend. See you on Monday.